Okay, welcome to completing the square part 2. What do you do if it's not as easy to see how to transform it into a perfect square? So with the equation in A, and anyone who is kind of growing familiar with what squares look like, you would see, oh, I just need that to be a 4, I can add 2. Well, what about this one? Because this is not so obvious in terms of like, how do I get that to be a perfect square? Let me give you some tools to be able to easily identify how to complete the square. And a lot of it involves kind of clearing the ground so you can see the equation in a more just in a better, in a clearer light. Let's put it that way. You won't always use these tools. Not everything is that complicated, but I'll show you all of them, and you can adapt it for your situation. So what I do first is I like to move the constant to the other side. So let me add 5 to both sides. 2x squared minus 6x equals 5. Okay, then if I have a coefficient on x squared, I'm going to divide that out from both sides. And you'll kind of, by the next step, you'll kind of see where I'm going with this. Then I'm left with x squared minus 3x. And I leave a little space, and you'll find out why. It's deliberate. Okay, now I am back to this situation. All right, this is the x squared. Right, coefficient here is 1. It's easier now to tell what is needed over here to complete the square, because what does this have to be? This has got to be the square of x minus half of 3, or plus half of whatever that coefficient is. Why? Well, that's the only way to get minus 3x as my second term. Right, there's my x squared minus half of 3x minus another 3 halves x, and then I'm going to have plus 9 over 4. We're going to use all of that. Okay, so that's my x squared minus, well, 3 halves and 3 halves, that's 6 halves, or 3. Minus 3x plus 9 over 4. That's it. That second term in your binomial is always going to be half of that coefficient, as long as 1 is your coefficient on x squared. So that's why I divide by whatever that number is. And you'll see later why I also move the constant over to that side, which you don't have to do. But I'm showing you when you're dealing with the most complicated things, that's helpful. And then you can leave out things that you don't need if it's not that complicated. Okay, so once you get it down to here, to recap, x squared with a coefficient of 1, then whatever this coefficient is, cut it in half, and that is going to be your second term in your perfect square. Okay? And I explained the logic for that, because you're going to have 2 of them when you multiply it out, and so that adds up to this. Okay. Now, since we know that the left-hand side has to be this is my perfect square. It's the only thing that will give me x squared and minus 3x. Now I need to find out, well, what number is going to go here? Right, that's what I can change. That's what I can adjust. Well, it's got to be 9 over 4. Because if it is x minus 3 halves squared, then when I multiply that out, I will get 9 over 4. Right? Negative 3 halves squared is positive 9 over 4. Okay. So then to complete this square, I'm going to add 9 over 4, And of course I can do that if I add 9 over 4 to both sides. Okay, so addressing this, I could have left the 5, it would have been 5 over 2 over here. I could leave 5 over 2 and then figure out, well, what do I need to do to turn that into 9 over 4? Well, I could subtract 1 over 4 because this is 10 over 4. You can do that. Again, sometimes it's not easy to do a whole bunch of mental math that way, but if you're up for it, you certainly can. So this is just one way to do it, where you kind of put the number on the right side so that in a sense you don't have to worry about it. You have a blank slate here to figure out, well, what number do I need? Okay, then once you add that to both sides, I think I have enough space here. Okay, good. Alright, so I know this side is x minus 3 halves squared. Okay, that's what I got from here to here. So now if I have this, I can rewrite it like this, equals, and then I simply add those two together. So that's 10 over 4, right? That's my 5 over 2, just multiplied by 2 over 2, so that I have a common denominator, and it's 19 over 4. Okay, and I did choose probably one of the most ugly completing the square situations possible. That was my scratch work. Alright, so from here, right, we'll do what we did with the square root property. Take the square root of both sides. X minus 3 over 2 equals, plus or minus, the square root of 19 over 4, which I can simplify as the square root of 19 over the square root of 4, which is 2. And then add 3 halves to both sides. 3 over 2 plus minus root 19 over 2, which then I can actually combine 3 plus or minus root 19 all over 2. And there is my solution for a quadratic that was unfactorable. Right, 10, no two factors of 10 give me negative 6, negative 10 I mean, give me negative 6. It doesn't immediately look like a square, but I can cause it to become one by adding 9 over 4.